Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 1.2.3, which deals with area as a product and area as a sum. Now, before we begin the lesson, we're going to actually warm up with problem 1-42, which is labeling the area and perimeter of each arrangement. Now, if we were in class, what I would do is I would hand you guys a Ziploc bag that would have all the algebra tiles in it, and you would get the dimensions based on the labelings of your particular algebra tile set. But because we don't have that, we're on the distance learning model, I'm going to show you guys using a virtual set of algebra tiles. So let's begin with just introducing what the algebra tiles are, and then we'll go forward with the lesson. So I'm going to peel off each algebra tile into this arrangement here, just so we can kind of just compare the sizes of each block. Now notice how the x squared and the x line up perfectly. That should make sense, right? Because one is an x squared, one is an x, and by doing that we will get the individual dimensions of each one as we go forward. Notice how the y squared is larger than the x squared, and that's okay. The y, likewise, just like the x, would be the same size as the y, but just a different width. A 1, if you notice a 1 has the exact same width as the x. In fact, I'll draw another one. I'll bring another 1 into here. That way you can see that the 1 has the same width as an x, and it has the same width as a y. And then the x times y, if I can just move these guys out, I'll move them all out like that. The x times y, it has the same length as the or the same height as the x squared, but it has the same base. It has the same base length as the y squared. So just important for us to know how to read these tiles. Now you can access these through your ebook if you want to, but for purposes of this, I'll probably going back and forth between the algebra tiles. That way you guys can see a visual model on the area as a sum and area as a product. So let's go and do the warm-up real quick. And what we're going to do is we're going to label the area and perimeter of each arrangement. So before I even get started, I'm going to go and label the areas of each of these blocks. Well, we saw from the previous slide that that's x squared, this is x, and these were all 1, 1, and 1. So how does that help me find the area? Well, remember, the area is really just the sum of all of the individual areas that you already see. So there are 3 of these little 1s in here, so it'll be 3. And then there's 1 of these x squared, so I'll add an x squared to it. And then 3 of those x's. So in this particular order, it doesn't really look nice. Most people would prefer this order where it's x squared plus 3x plus 3. The perimeter I will take care of in a second because it gets a little complicated, especially with this with that dimension right there. But don't worry, I'll take care of perimeter. With the area here, I'll do the same thing. This is going to be y squared, that's going to be x squared, and this is going to be 1 and 1. So if I had to add these up, I would say y squared plus 2 of those x squareds, right? 1 and 2, plus another y, and then plus 2 of those 1s. So again, just the summation of the area. It's not that hard. We're just adding up the individual areas inside, and we're just going to add them all together. Of course, we can't simplify any further than that. This is as simple as it gets. We can't combine like terms. We have no idea what x and y really are. Okay, so perimeter. Perimeter is the distance that I have to run around this particular building. So let's go and talk about that for a second. Now, from the areas, we have to extrapolate individual dimensions. So because this small little square has an area of 1, I hope it makes sense that the sides are both 1 because 1 times 1 is 1. Making this 1 also. Making this a 1 on bottom, and then a 1 on the side here as well. A 1 will show up on bottom here. Now this thing here that I'm going to label in orange, I don't know what that is. This is this little segment right here. I'm just going to put a question mark right there. We don't know what that is right now. Now, if you look at it, we won't be able to fit a third block in. In fact, I can even show you using the algebra tiles. I'll bring out an x squared. I'll bring out a 1. I'll bring out a 1. And I'll bring out another 1. You see how it just barely doesn't fit, right? There's still space for a little bit more, and there's no other block that will allow me to fill in that gap appropriately. See, that doesn't match up. It's almost like you're playing with Legos where you're looking for that right piece, but you just can't seem to find it. So you notice how the 3 1s aren't going to fit into here. So that little space right here is going to be kind of odd, but we'll figure out what that is in a second. With the again, going on with more dimensions, because this is a square and its area is x squared, that means that the base length is x. The height is going to be x, but I'll cover that when I get to the right side. Before I showed you the small block stacked on top of the rectangular block, meaning that they have the same base dimension. The height of this block is x, another 1, 1, 1. This is another x. So here we are at the orange thing. Okay, how do we find the dimensions of the orange thing? That's going to be a little tough. So from here, what I do is I look at all of this. I look at all of this space right here. And what I do is I say, how much is all of that? Well, all of this is identical to all of this in orange as well. Well, that's x. The problem is I don't want all of that orange thing. I'm going to cut off the parts that are green. So whenever I cut off something or I eliminate something in mathematics, that is indicative of a minus sign. And what did I really remove? Well, I removed a dimension of 1 right here because it's equal to that 1, and another 1 right here because it's equal to that dimension there. So it's really x minus 2, and that is the perimeter. Oh, not that is the dimension of this small little orange side right here. This small little orange side is x minus 2 units long. Now, in order to find the perimeter, I have to do something kind of tedious, which is going to be 1 plus 1 plus 1 plus x plus 1 plus 1 plus 1 plus x plus 1 plus 1 plus 1 plus x minus 2 plus 1 plus 1 plus 1. At the end of the day, when you add up all of these terms on the outside, because remember, we're finding perimeter, we end up with 4x plus 10. Let's take a look at number 2 right here. So again, I'm going to go and find the dimensions of the outside pieces, the length of the width, the length of the base. So that's y and y because it's a square, y squared, x and x and x. X is all around. I'm going to go and call this dude in purple because I don't know what that is. That's the same sticky situation as the x minus 2. But I can label everything else if I want to. This is 1, 1, 1, 1, 1. And you know what? This thing here in green, I don't know what he is either. So again, let me show you why. I'll go back to the algebra tiles. Where are they? They're right here. Okay, so if I do this, right? If I do this, if I bring out a couple of 1s, notice I got a 1, oops, I got a 1, I got a 1. Let me see, oops, I will copy and paste. Okay, cool. Notice how 4 1s, right? 4 1s, if you zoom in right here, it actually isn't quite long enough to hit right there. It's actually not quite long enough. So from here, we can't really use 4 1s to carry out, to fill in that gap. Same thing here. If I put an x squared right here, if I take a 1 from here and another 1 from here, now I've got too much block. I can't find anything that magically fits. So how do I do this? So from here with the green, I say, well, all of the green, well, that's worth y. But I don't want all that. I'm going to subtract the pieces that I don't want. So what do I subtract? I'm going to subtract the things here in red, and that's worth 2 long. So it's y minus 2. And then the purple, again, how much is all of this? This is all a y length. But again, there are pieces that I don't want. I'm going to eliminate this thing here in red. How long is that? Well, it's worth x. So I will replace that with an x. Wrong color. So, in order to get the perimeter, it's going to be y plus x plus x plus x plus x plus x, all that stuff all the way around. After it's all done, you end up getting 4x plus 4y plus 4. So hopefully that makes a little bit of sense. I'll be back in just a flash with the next piece of the resource page. Alright, we're back in 1-43. And it says we have a three-part problem here. We got to sketch a rectangle, so that's part A. I'm assuming part B is area as the sum of its parts, and area as a product of its dimensions is going to be part B, and then part C is the equation. Okay, so before I sketch the rectangle, we'll probably do this in the algebra tiles thing also, but actually the easiest question in 1-43 is really the area of the sum of its parts. And so from here, we could, regardless of how we put this thing together, there's going to be one of these x squareds. So I can put that down. Whoops, I'm going to change colors around, change it back to red or black. It's going to be x squared, okay? And then, how many x's do I have? I have 1, 2, 3, 4, 5, 6, 7. I have 7 of those x's, so I'll put those in. And then I've got 1, 2, 3, 4, 5, 6 of those tiny pieces. So actually the area as the sum of its parts is actually not that hard. Now the area as a product of its dimensions, before we even do that, let me talk about what we're about to do. It says sketch the rectangle. Now notice they emphasized rectangle, which means we're going to be constructing a rectangle here. So let's get that in our notes. I'll change this to red. We will be using the algebra tiles to construct a rectangle. Now, why are we constructing a rectangle? The reason why we are constructing a rectangle, whoopsie. I don't know why the program doesn't. This program kind of glitches out a little bit. We construct a rectangle because remember, this is an area problem, right? And so we construct a rectangle or a square. Because those shapes have areas that are easy to find. Okay? Because the area of a rectangle or a square is pretty simple. It's base times height. Or length times width, or whatever dimension you decide to call. So it's base times height. So again, we're going to construct the rectangle here. So I'm going to go back to the virtual algebra tiles, and we're going to construct this. So let me go and pull that up. Goodbye to all of you. So we have one of those x squareds. We have 7 of these x's. So I'll go and copy and paste them in. 2, 3, 4, 5, 6, 7. And then we have one of these unit tiles. Or sorry, 6 of these unit tiles. I apologize. So 6 of them. So we got 1, 2, 3, 4, 5, 6. Now my objective is to create a rectangle. Now the dimensions are going to vary sometimes between people depending on how they construct the rectangle. But at the end of the day, the linear dimensions, the perimeters, will always end up being the same. So let me show you guys what that looks like. I'm going to go and do here. I'll just go ahead and do 4 rectangles this way. And then I'm going to twist these guys on their side and put them here. Now these 6's, or the 6 ones, I think I can go ahead and just, line him up. I think I can go ahead and just put them in like this. Put them in like that. Okay, so clearly that is not a rectangle. So if I'm going to create a rectangle, I have to kind of rearrange the thing. So let's see what happens if I rearrange this thing. I feel like oh, there we go. All right, so now if I just rearrange some of my stuff, I might be able to, voila. That's okay, and it's okay to not be able to construct a rectangle in the beginning. But right here, this is the rectangle that I'm going to construct. So from here, I'll go and copy that onto the answer, or back onto the paint program. And so here's my rectangle, and now from here the rectangle is helpful because the rectangle allows me to now figure out the dimensions of the sides. So from here, just like last time, just like up here, I know that this is an x, I know that this is an x. I know that each of these is 1, and there's 4, 5, 6 of them. So this is a total of 6. And if I wanted the full dimension, I would add these two things together. I know that this guy has a dimension of 1, and I know that I would add those guys together. So again, how do I express area as a product? Well, again, that's base times height, right? So the base is x plus 6, and the height is x plus 1. So from here, the area expressed as a product is base times height. And I got that by constructing a rectangle. So remember, I messed up in the beginning. I created some weird-looking Tetris piece. That wasn't going to help. I always want to construct a rectangle with these algebra tiles. So from here, the equation is going to be, well, remember, we're just trying to find out that these two answers are exactly the same, right? So we could then say that x squared plus 7x plus 6 is the same thing as x plus 6 times x plus 1. That is 1-43. I'm going to get 1-44. I'll be right back. All right, and we are back with 1-44 here. So what we're going to do is we're going to do the area model on 4 problems here. Again, we're going to take each of these. We're going to express the area as a sum and the area as a product. So how do we get started? Well, the area as a sum is actually pretty easy. It's exactly the same thing as we had. It's the summation of the interior areas all together. Okay, so that one's actually pretty easy. So we could fill out all 4 of these if we wanted to because they're all the same, right? And so again, what this is an expression of is it's an expression of the summation of all the interior pieces. So x squared plus 2xy plus y squared. Okay, cool. So that part's done. Let's go and take a look at the area as a product because that's going to be where things get a little bit trickier. So let's go and go back to the algebra tiles here. So goodbye to those. So in the first problem, we have x squared plus 8x plus 12. So I'll take an x squared. I'm going to take 8 of these. So I'm going to copy him. And I'm going to paste him 2, 3, 4, 5, 6, 7, 8. And then 12 of these guys. So copy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I believe that's 12. Okay, cool. We'll find out soon enough. So again, my mission, I have to try to construct a rectangle from this thing. So just to save time, I kind of know what rectangle I'm going to create. I'll go and throw that guy down there. I'll throw that guy down there. I'm going to throw one up top. Throw one up top, throw down, throw, oopsie, down, and throw down. Okay, so now from here, these guys now are going to fill up the rest of the gaps. Whoops. So now I've got one, whoops, I lost him there. So I'm just going to fill in the spaces. Again, my objective is to try to create a rectangle. Why am I trying to create a rectangle? I'm trying to create a rectangle because that is a shape whose area is easy to find. So now that we have our rectangle here, I'll go and copy and paste him into our document. Right here. Okay, we have a perfect rectangle. So now we just got to find our dimensions. So that's going to be an x and an x here. These all have a dimension of 1. So that looks like 1, 2, 3, 4, 5, 6. So plus 6. These have a dimension of 1, so plus 2. So area as a product is base times height. So that's going to be the x plus 6 because that's the base, and then x plus 2 because that's the height. So let's take a look at the next problem, 4x squared plus 4x. So, oops. Darn it. So 2, 3, 4. 2, 3, 4. Okay, 4x squared plus 4x. Here we go. Let's go and construct this thing here. So if I do this, I put them down like that, I think I can get away with just kind of putting these x's like right here and creating a rectangle. Now there's a few different ways to do all of these, and it's not a huge deal. But I'll go and move him down. Okay. Actually, you know what? Because I want him to fit on the page, I'm gonna go ahead and make him sideways. So it'll just be a sideways version of what I had. Sorry, it's not that the other one wouldn't work, it's that it's too tall for the page to fit on. So I'll go ahead and do that. Copy him in. Paste. Alright, here we go. I suppose I could have put the tall one on the side there, that way you can see that they were the same thing. And so from here, let's go ahead and get our dimensions here. This is an x and this is a 1. This is an x and an x and an x and an x. All of these guys added together become 4x, and it's base times height, so it'd be 4x and then parentheses x plus 1, base times height. Okay, let's take a look at the next one. 2x squared plus 7. Actually, no, I said I was going to do this one vertically. So let me do this vertically real quick here. So boom, boom. Move you guys a little bit down. There we go. Boom. And boom. Okay, so now if I was to do this, one, the dimensions are a little bit different, but it all ends up equating to be the same thing. So paste that guy in. And I want to show you that they're going to be the same. Okay, so look at the dimensions here. Here, this is going to be 4x right here. This right here is x plus 1. So again, base times height is going to be x plus 1 times 4x. Now, of course, you guys know that when you multiply, the order doesn't matter. So either way you cut it, you end up with the exact same thing. So hopefully that makes a little bit of sense. Let's go and take a look at the next one. 2x squared plus 7x plus 1. So just eliminate those guys. I need 3 more of these. So 1, 2, 3, and then 1 of these. Okay, so something should kind of stand out here. I feel like it should make a little bit of sense right here. I don't believe there's anything I can do to make a square out of this, or a rectangle. I mean, I can't really see anything that would allow that to happen. So when something can't be made into a rectangle, right? Even if I put this guy here, there's too much of a gap right here. I can't do that. When there's too much of a gap and you can't create a rectangle, then all you have is an area as a sum, and you don't have an area as a product. Whoops, wrong color. And then the last one, x squared plus 2xy plus y squared. We'll take a look at that. So x squared, I need 2 of these xy's and then a y squared. So here what I'm thinking is I'm going to line this up like this. I might be able to flip him over and put him like this, and then this guy should be able to fit and make a perfect square. So I will go ahead and do that. Okay, so this one's going to be a little bit trickier because we have x's and y's going on here. We know that this is x and we know that this is y. We know that this is x and we know that this is y, making this x plus y times x plus y. Now some people might get a little more fancy with it and call it x plus y squared. Either way, I'm fine. So I will go ahead and leave it right there for a second. I'm going to grab the next page and I'll be back. Alright, we are on the last piece here. Area as a sum, area as a product. We're on 1-45. So area as a sum is not that hard. We're just going to add up the individual areas. I count 6 of those x squareds. I count 13 of those x's, and I count 6 of the number 1's. The area as a product might get a little bit trickier, only in the sense that we have to now start counting more complicated things. So it looks like this is x, 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 and then 1 and 1, making it 3x plus 2. And then this is x, x, 1, 1, 1, and then making it 2x plus 3. Again, area is a product, right? This would have been the base, this would have been the height. And notice how it makes a perfect square or rectangle. That is what allows us to create what we call factors that look like that. Alright, so the last piece here, 1-47. Now they're not giving us any more direct pieces. Now notice how in this one there were 6x squareds and we were given literally 6x squareds. Now in 1-47 they're giving us 3x squareds, but they're all combined together in one block. Now we're supposed to use a little more imagination, a little more mind power for this thing. So from here, the area is given as 3x squared. The base dimension is x. So when I look for this vertical dimension, I'm basically asking myself, x times what is 3x squared? Well, I believe it's x times 3x gets me 3x squared. And now that I have 3x squared, it's kind of like putting together a puzzle. It's like, if you have 3x squared and this is 6x, I got to find out what this guy is. So 3x times what is 6x? I believe it's just 2. And then once you have that done, now you can express this rectangle as an area of product and an area of sum. So the area of the sum is 3x squared plus 6x. But that is also equal to 3x times x plus 2. All right, here comes B. So they have an x plus 1 up here. This is an x. This is an x squared. The bottom dimension has to be an x in order for that to be true. The bottom dimension here has to be a 1 because the 1 multiplies by this x to give us positive x. So that's good for that. The top left box is a 1 times an x, giving us x. And the last box is 1 times 1, which is 1. So from here, if we were to write this as an area as a product, it would be x squared plus, looks like plus x plus 1. In other words, x squared plus 2x plus 1. That's the area written as a sum, the area as a product. The base is x plus 1. The height is x plus 1. In other words, x plus 1 squared. All right, let's take a look at C. C is a little more complicated. So from here, a 2 is up here, but it becomes negative 4x. So it makes me think that a negative 2x goes down here, because negative 2x times 2 is negative 4x. So now from here, what else do I know? I know that 2 times 3y is 6y. And then I have to figure out some other things as well. So this vertical side is a 2, meaning this vertical side is a 2. I need to make this negative 10, which means I believe this goes to negative 5, because negative 5 times positive 2 is negative 10. So from here, what else do we know? We know that this top box here, we know that the top here has an x involved. So how can I get that? Well, from here, this 3 becomes a 3xy. The only way that can happen is if it had a height of x. So from here, I just have to figure out what each of the pieces combined is. So this is going to be x times negative 2x, negative 2x squared. And then x times 5, or negative 5, is going to be negative 5x. So what you could say then is you could say that negative 2x squared plus 3xy minus 9x, I just combine out the negative 4 and the negative 5, plus 6y minus 10 is equal to x plus 2, negative 2x plus 3y minus 5. And then last problem, D. Here we go. So we've got, again, a 2x here, a 4x squared. We're missing a dimension. The only thing I can go in here would be a 2x. 2x and positive 3 becomes 6x. Now this 3 becomes a negative 9 as long as this guy was a minus 3, which makes him negative 6x. So what you get is you get 4x squared plus 6x minus 6x minus 9 equals, in this case, 2x plus 3 for the base, and then 2x minus 3 for the height. Okay, that was a pretty involved lesson. I hope you guys got something out of it, and as always, please leave questions in the discussion area, and I will see you in the next episode.